Hello and welcome to another video. In this video we're going to be working on check if array pairs are divisible by k. And in this one you're given an array of integers of even length and an integer k, and you want to divide the array into pairs such that the sum of each pair is divisible by k. Return true if you can do that. So in this one you can, and here's all the pairs. And in this one you can as well, looks like. And then in this one you can't, and we'll go over why. So the main thing is like let's say k is 5, and I have a number like 3. What number can I add to 3 to make it divisible by 5? And so if I have two numbers and I need to add them, then basically the remainder, or the modulo of, so if I have like x and plus y, in order for this to be divisible by k, in order for this to be 0, that means that x plus, or x mod k plus y mod k has to equal 0. And so the other way of saying that is basically the remainder of x mod k and y mod k added together have to equal k. And that makes sense, right? Like if I have a 1, that mod 5 is 4. And so, or it's actually just 1. And so I need to add something that number divided by 5 also gives a remainder 4. Because then that extra part, those extra parts added together will be 0, right? So you basically can treat it as like if I divide this and this, these two remainders have to add up to k, because yeah. So actually this is not true. This has to equal k. Yeah. Because in order, if that is the case, then that would be 0. So for example, 1, I can add something like 4, or I can add something like 14, or I can add like 9, and all of these will work, right? Because 9 mod 5 is 4, and 1 mod 5 is 1. And so these added together are k. So when I have a value, it's pretty easy to figure out what the other value should be, right? So so let's try another number. Let's say if our value is like 3, well, 3 mod 5 is 3. So we need something that mod 5 equals 2. So some values are like 2, 7, 12, and so on. And so now that you know, like given a number, what should the other number be, or what should the remainder of the other number be, we can basically just store remainders. And then when we have a remainder, we can see like, okay, well, what's the other remainder we need? And if we have that, then we can remove both of those, and then we can find all our pairs that way. So let's kind of walk through these examples now knowing that. And so we're going to have a hash map of a remainder and a count. So for example, for 1 mod 5 is 1, and we're going to say, okay, well, we need 1 plus something to equal 5. So we need 4, right? So we do k minus k minus 1 equals, so we need something that has a remainder 4. Do we have anything? No, we don't. So we're just going to store this remainder 1, and we're going to have a count of 1. And then for 2, I'm just going to start writing these out faster. So for 2, actually, instead, let's just do it this way. Let's just make an array. So here's all our numbers. Yeah, that'll be faster. So here's all our numbers. Get rid of this guy and just make it like this. Okay, and let's just write all of our remainders really quick as well. So actually, let me go back here. There we go. Okay, so for all of our numbers, let's write down the remainders in this box. Yeah. So this is like 1, 2, 3, 4, 0. 1, 2, 3, 4. Okay, so these are all of our remainders if k is 5. And so when we go through these numbers, we can just see, like, do we have the opposite? So for 1, we have to check, like, do we have a 4? No, we don't. So we're going to store 1 with a count of 1. For 2, we need 3, because 2 and 3 add up to 5. We don't have that, so we're going to store 2 now with a count of 1. And then for 3, we need 2, because 3 and 2 add up to 5. So do we have a 2? Yes, we do. So we can get rid of this now, because these two make a valid pair, right? This is remainder 2, remainder 3. Both of these remainders add up to 5. So we're done there. 4, we need a 1, and we have 1, so we can get rid of that, right? So these two are a pair. And like I said, you can have any pair you want as long as the remainders together add up to k. So this is a pair as well. 0, so this is the exception. So for 0, if something is perfectly divisible by k, the number we need to add to it also has to be perfectly divisible by k, right? So basically we need another number that's perfectly divisible by k. We don't have that. So yeah. So then let's just store the 5. And actually, looking at this, we're missing one number. We're missing a 10. Looks like it's 1 through 10. So for 10, this is 0 as well. So here we'll just store remainder 0, count of 1. Now same thing. We're going to store a 1 with a count of 1. We're going to store a 2 with a count of 1. And then when we look for it here, we're looking for the 2. So basically I can draw out these pairs. So this is a pair, this is a pair, this is a pair, this is a pair. And then when we get to this last number, then we're going to say, oh, we need another 0, which we have, and then we get rid of that. And we can basically just get rid of numbers out of the hash map. Like if we have the complement, we will get rid of both. If not, we'll just store the current number, and then we can just check, is our hash map empty, and did we make all our pairs? So in this case, we did. So let's look at the second example. The same kind of thing. Yeah, because these examples are pretty short. So the next one looks like it's 1 through 6. Yeah, and k is 7, so let's do the same thing. So k is 7. So let's write down all of our remainders. This is 1, 2, 3, 4, 5, 6, I believe. I think so. Yeah, okay. So same thing. We need our remainders to add up. So basically, once we store these remainders, do we have pairs that add up to 7? Yes, we do. So we'll store the 1, we'll store the 2, we'll store the 3. And then for the 4, we need a 3, because 4 plus 3 add up to 7. So this is pair, pair, and pair. So once again, this is going to be fine. And then the last example, k is 10. So what am I doing? Okay, k is 10. And we have 1, 2, 3, 4, 5, 6, so same thing. So we need pairs that add up to 10. So this adds up to 10, but nothing else does. So we can't actually do this. So that's kind of the idea. Hopefully it makes sense. Basically, when you do modulo arithmetic, if you have remainders and you add them together, then those remainders have to be divisible by k in order for the number to be divisible by k. I think once you look at a couple numbers, it's pretty intuitive. But that's basically our solution. So we're just going to store hash map of remainder and count. And then whenever we get the complement, we'll get rid of the pair. And then we'll just check is our hash map empty at the end. Let's do that. So say map. I don't think we actually need a map here. I think we can just use an array to make it better of remainders. So we'll just make an array of 0 to k minus 1. Yeah. Remainders equals. It's going to be like k. Okay, and then we have to go through all of our numbers. So for and num in array. So if it's 0, we'll check for the 0. Actually, we don't need to check for the 0 case. Actually, we should check for the 0 case. So the way we could do it is this. We could say complement equals, yeah, so we could say complement equals num mod k. So it's really k minus this. Yeah, so it's k minus the remainder. And then if the remainder is 0, then we want this whole thing to be 0, so we can actually just mod by k again. I think this will be fine. Because basically, like, let's say the num is 10 and k is like 5. This will be 0. So we'll have 5 minus 0, mod 5, which will be 0. And if this is like 1 and k is 5, then this will be 1. And then this will be 4, and then that will still be 4. So this is fine. So this is the complement we're looking for. And if the complement exists, then, yeah, so if the complement exists, then we need to lower the count of the complement. We don't even have to check for that, to be honest. Actually, no, we probably should. So, yeah, so if rems complement greater than 0, then we'll just lower that. So we just lower the complement. Otherwise, we will raise the mod, which is num1k. Okay, so if the complement exists, we basically get rid of one of those. If not, we'll add this value in. And then we just have to check in this array, every single value has to be a 0. So we can just say like for int num in rems, if num it does not equal 0, return false. And return true. Okay, that should be fine. Int. Okay, let's see. Index out of bounds. In this case, let's see. Oh, right. So I guess in Java, negative numbers are weird. So for negative numbers, let's just make it positive. So -1. For a number like -1, let's say k is 5. Yeah, so let's say like we have -1 and k is 5. We need to basically add here to make it 0. We need to add 1, right? Or something with a remainder 1. So we can just say, can correct this, so we can say if complement is less than 0, then let's just get the positive version of that, which is k minus complement. So for -1, this is basically the same as having a remainder 4. So we can just invert it that way. And this can be like way bigger than k, which actually I think should be fine. Well, yeah, actually let's just change, instead of doing that, let's just change a number to a positive number. Yeah. So if number is greater than 0, let's just change it to a positive number. And basically the way we want to change it to a positive number is we want to get the remainder and then do k minus that, I think, something like that. And I think the way we can do that is we can just say like num equals absolute value of the number mod k or something. Yeah. So we actually need just the remainder of the number. So if we do this, then we want the opposite of that. So to be like k minus this, I think. So for -1, we would get a 1, and then, yeah, I think this will be fine. Let's see. Okay, there we go. Okay, so basically, yeah, remainders are kind of weird in Java. Like, they don't work the same way. So basically, we're turning the number from a negative to a positive. So if our number is like -1, we're just saying, let's turn into a positive 1, get the remainder, which will be 4, and then let's get the inverse of that, which is just k minus 4, which is 1, which is what we want. Yeah, okay. So there's like a bunch of other ways to do this, and depending on language, you might not have to do this. But hopefully it makes sense why that is the case, because, yeah, basically the remainders work differently with negative numbers in different languages. So, yeah. Okay, so, yeah, so this is fine. And then, so this is linear, and the space is O of k, because we're storing remainders. And I think, yeah, I mean, k can be bigger than the array. Technically, you can make it, if you use a hash map, then it won't be O of k, it'll be like O of min, and then k if you use a hash map instead of an array, so up to you there. Because, like, if you only have 5 numbers, you're only going to store 5 remainders and so on. So, yeah. But in this case, with an array, it's okay. And yeah, that's going to be all for this one. Hopefully it's helpful. If it was, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.